Today I'm gonna explain you the LeetCode 1664 ways to make a fair array problem. So this is very pretty interesting problem. So in this problem what you have to do is that you have to make array fair. Fair array is an array uh, in which the sum of elements at odd index is equal to sum of elements at even index. So we have to give an array and we have to make this array a fair array. So we have to count how many times we can make the given array fair array. So there is a condition like if in array we can delete one element at a time, and after that we can check that the array is fair array or not. So if we have n elements in an array, so at each step we can pick one element, delete it, and we can check that given array is fair array or not. For example, if we have given a array, for example in this case 617671, so this is a given array, so we need to check that given array we can make this given array a fair array by removing first element, second element, third element, fourth element, fifth element. So when I remove first element, the resulting array will be 1741, and we can check this array is a fair array or not. So as I already told you that fair array is an array if sum of element at even index is equal to sum of element at odd index. If that condition met after removing exactly one element from the array, then that array is a fair array. So we need to check this for each element in the array. For example, if in this case 1, 2, 3, 5 elements, so we can check this 5 times by removing element at location 1, 2, 3, 4, 5, and we can check that given array is fair array or not. So if you hope you understand this problem well. Whatever I explain you is written in this statement. So you can also go through this statement to understand well what I've said. So we are also given some example test cases, so you can also go through these test cases one by one and to have a better understanding of these kind of problem. So first thing is that we need to build up a logic, and how you can build a logic. Most of the thing we have seen that most of the guys just read this statement one time and quickly start doing the coding, which is not a best practice, because in that way if you don't have a logic in your mind, you will stuck somewhere else, or you will not able to complete this problem, because at some point of time if you miss any of the scenario, your test cases will not pass. So might be if you are writing your logic based on these given three test cases, I'm sure that you will able to pass these test cases. But when your solution will run on multiple test cases with multiple scenarios, in that case your solution will not pass, because it can be failed at some test case based on some condition or scenario which you didn't imagine while writing the solution for this problem. So best thing is that just try to understand the problem. Just try to understand what problem says. After that, try to write your own test cases. Try to make your own scenarios to have a better idea of the problem. So the given three test cases just give me insight that how I can approach this problem. But still, because on first look I can go through order of n square solution, but that I'm not gonna pass because of constraint. So here constraint is 10 to the 5, and I need to solve this problem in linear time. There is no other way of doing this problem like solving it n square or more than that, because in that case the solution will give you TLE. So first, whenever you pose this kind of problem, first try to find out the brute force solution, because when you write your brute force solution, that give you a clear picture of the problem. That will give you a clear picture of all the edge cases, all the scenarios. So first step to write the solution to the problem is write a brute force solution, and after that see how you can optimize the solution. What are the things that are being repetitive, and how you can avoid those repetition by storing those results somewhere else and using those results whenever required while solving the problem. So same approach I have used in this problem, because what I first observation is that I found it while going through this problem is that whenever I remove any element, for example if I remove 1, then all the element right of that uh, element will decrease in their index by 1. For example, if I remove this element at location second, then this 6 will become, index of 6 will become 2, and index of 4 will become 3. So from here what I found is that, because once I remove this element, after that we need to find out the sum of indexes at even and odd places, and to check that sum uh, of these even and odd indexes is same, to see if array is fair. So in that case, because if I remove first element, then again I have to sum at the element at the odd and even places and see if that sum is equal or not. So at every point, at every index, when I remove an element, what I'm doing is that I'm repetitively doing the sum of my odd and even places element. So which is kind of repetitive. So that leads to n-square solution, but because constraint is very limited, so I have to think that how I can store this uh, you know sum of odd and even places element. So what I have to do is that I have to store sum of even and sum of odd places element somewhere else, and after that I can reuse that prefix or postfix sum to find the solution. So here in this case, what I can do is that first I will prefix sum at even places and prefix sum at odd places, because suppose that when I remove element at index 1, then I have to check all the sum of elements at odd and even index to the left of that element, and sum of elements of even and odd index to the right of the element. So I will do post prefix sum for even and odd elements. So once I done that, at each and every step what I can do is that, for example, if I remove 6 here, then I will have to do 1 4. So whatever the element which are right to the 6 and whatever the element to the left of the 6, So I will add some of even indexes to the left and some of odd indexes to the right, because when I remove this element like 6, it will change even index element to odd and odd index element to even. So that's the crux, that's the logic behind this problem. So let me tell you with the solution. Like here, one thing is that if length is 1, answer is gonna be always 1. That is one case. After that, what I did is that I created 4 arrays which will contain my prefix and postfix sum of even and odd places. So here I am checking that my last element is even or odd. If my last element is even, then I start with the even. If last element is odd, then I will start with the odd. After that, I will do the prefix sum of even and odd places of the array element, then prefix sum of even and odd places of the element, or postfix sum of even and odd places of the elements. So once I did that, so I have all the pre-calculation in my even and odd arrays. So then I will start iterating one by one, and as I already tell you that if I remove a particular element at an index, all the elements index will on the right of that array will change into, for example, if any element which is right of the particular element that we are deleting will change into, if it is even, it will change into odd, and if it is odd, it will change into even. So that's what I am doing here. So if I is equal to 1, if I is equal to 1, so 2, let me give you an example, 2, 1, 6, 4. So if I am deleting this element, so all the element to the right of this array will change their index. For example, if element is at even position, it will change to odd, and if it is storage, it will change to even position. So because when I is equal to 0, if I am removing element at 0 location, there is nothing to the left side, so only I have this. So that's why I have used even last equal to odd last, because we will use this postfix sum of even and odd element array. If I am removing any element which is greater than 0, for example on there, then I have this array and this array. So this is my prefix sum and this is my postfix sum. So even this plus odd, because removing this, all the odd will change into even and even will change into odd. So that's why I'm adding even with odd and odd with even. And same case with the last element. So hope you guys understand this problem. Thanks for watching.